Okay. Well, here we are. Another week. This is week number 4, where we're going to go through 2 more modules in the network security class. The first one will be the AAA. Starting with the characteristics. The simplest method of remote access authentication is to configure a login and password combination on a console, on a virtual line, an auxiliary port, or other ways as shown. This method provides no accountability. Anyone with the password can gain entry to the device and alter the configuration. SSH is a more secure form of remote access. It requires both the username and the password, both of which are encrypted during the transmission. A local database may have some limitations. The primary one being you have to configure those accounts locally on every device. So AAA and not this AAA is the way to do the 3 items in order to administer security throughout the environment. There's authentication. Users and administrators must prove their identity before accessing the network and the network resources. Authentication can be established using username and password combinations, challenge and response questions, token cards, and other methods. There's authorization. After the user is authenticated, authorization services determine which resources the user can access and which operations the user is allowed to perform. Then there's accounting. Accounting records what the user does, including what is accessed, the amount of time the resources accessed, and any changes that were made. Essentially, it keeps track of how the resources are shared. The 2 ways are local and server-based. Locally, we have a database for that authentication. It's otherwise known as like self-contained authentication. The server-based, a router in this picture, would access a central server that would then take the username and password from all devices, run it through things like the remote authentication dial-in user service or Radius. Could also take it through the terminal access control system, the Cisco specific protocol, in order to get this user connected. Once the user has successfully authenticated, either local or server, then they'll be authorized for a specific network resource. Accounting is the implemented use of the AAA. This service reports usage statistics back to the server. They can be extracted to create all kinds of detailed reports. Things like the type of network, the type of connection, the level of exec used, the system, what commands were used. Yes, if you don't want a device like a router to contact any other system, you could use local-based AAA. But that's, again, the big problem about that is if that user needs to connect to another system, then you have to make users at every system, and they won't be consistent across the board. Accounting is just another way of saying logging. It's the same thing. So when a user logs in, they get authenticated, and then we record that they logged in, they were successful, and they accessed X, Y, and Z resource for this amount of time. So it's enabling logging for folks who log in for all authorizations. It's not confined to a single premise, but this is just specifically for folks logging in, for successful and failed login attempts. Locally, for the realm of Cisco devices, it's very similar to the login local command with an exception. AAA provides a way to configure backup methods for authentication. So you have to add the usernames and passwords to the local router database. You enable AAA globally. You configure any parameters, and then you confirm that everything works. So in this example, you have the command to enable it. Do you want to enable it on the console, on the auxiliary, on the virtual lines? The default keyword applies to authentication to everything. Alternatively, you could have authentication methods that can be configured using something like a list name. You can list 4 methods to authenticate users, providing a fallback should one not be available. Anything that's local, you could use the keyword local or local-case. If you want to specify that a user can authenticate using the enable password, they'll use the enable keyword. For some flexibility, different method lists can be applied to different interfaces. The named list must be explicitly enabled on the line using the login authentication line configuration command. If a line has a custom authentication method applied to it, that will override any defaults. When a custom authentication method list is applied to an interface, it's possible to return to the default method just by using no authentication login command. I know, right? Super secret password there. Additional security can be implemented on that specific line using the AAA local authentication attempts max fail in global config. This command secures the AAA user account by locking out accounts that have excessive failed attempts. It will remain locked until manually cleared by an admin. So it is possible to enable AAA and still be open to brute force until you set this up. Then brute force is no longer feasible. So you can set all this up, and that's great. But you also got to close that hole. Oops. There we go. In the server-based implementation, getting away from local databases so that we centralize, and our users will be a little more happier that they can use the same username and password to log into multiple devices. You can use multiple AAA servers to manage those users and their access throughout a corporate network. A AAA server software can create a central user and admin access databases to which all devices in the network can refer to. It could even work with external databases like Active Directory and lightweight directory access protocol. since those already store user account info and passwords, you could connect it all together to AD and use that username password for everything, basically going single sign-on. Cisco has an identity service engine. It's a platform that enables enterprises to enforce compliance, infrastructure security, and streamline operations all in one. It has things like policy definition, control, reporting in one appliance. So you'll see things like your assets, the posture assessment, any segmentations, guest management, and threat containment. The other common child of Cisco's in this realm is the one that is weirdly mentioned, TACAX Plus. This is a Cisco specific protocol. So Cisco devices know how to use it. The rest of the world uses Radius. Yeah, Tic Tacs. But just so you know, that this is a specific Cisco protocol that shows up on tests and other certification exams. The plus is just like everything else that we use a plus for. It's supposed to be enhanced. The plus protocol provides separate AAA services. So it's possible to use one method for authorization and accounting and a different method for authentication. Kind of a lengthy process. It's 12 steps. Like AA, 12-step program. Radius is half of that. Radius works in both local and roaming situations. It combines authentication and authorization in one. Like I said, it is widely supported by many tools of different vendors because it's an open source. So to set this up, to configure server-based AAA, it's really 4 steps. We have to globally enable AAA to allow the use of those elements. Duh. Just like we have to turn on an interface in order to use it. Same thing. You have to specify the server that'll provide those AAA services. We configure the encryption key that will be used to transfer data between the networking device and the server. And then we configure the method either for Cisco Zone or Radius. And it is possible to configure redundancy so that we can add another server or multiple servers just in case server A dies on us. Because, you know, it happens. Here's what it takes to configure for Cisco's protocol. We have a new model. We add the server, add its address. We can use single connection to enhance TCP performance. If you have multiple, then you can add more under the server name command. And then the key that'll be used to communicate between the two. Radius is similar. We still have to make the new model. We add the Radius server. We add its address and other important information. And we also provide the key. Once the server is identified, you have to include them in the authentication login command. They're identified in groups of either Cisco zone or Radius. If you want to configure a method list for the default login, and say you wanted Cisco's own first, second to Radius, you could do something like this. And in this case, actually, it's 3. You got servers, you got Cisco's own protocol first, Radius second, and third, local. So in this case, a user trying to log in, when they give their username and password, they would first go through Cisco's protocol. If that didn't work, we're going to check out Radius. If that didn't work, we'll do local. iOS is interesting to learn. The commands are different. It's a little weird. Different levels to do things in. I think for me, that was the hardest part, was trying to figure out what command works at what level. So I don't blame you that it isn't a walk in the park to use. The good thing is there's a lot of help for it. So a command that you have an idea for, you can get what you could possibly use. And of course, you can always Google. So I wouldn't feel too defeated over not fully grasping iOS like you do like Bash or PowerShell. So configuring the other 2 A's in the AAA when talking server-based. Like I said, authorization is concerned with allowing or disallowing authenticated users to access functions of the network device. The Cisco protocol allows the separation of authentication from authorization. A router can be configured to restrict the user to perform only certain functions after successful authentication. Radius does not separate the two. The Cisco-specific protocol establishes a new TCP session for every authorization request, which can lead to delays when the user enters a command. In order to get around it, Cisco made persistent TCP sessions. That's what you do when you hit the single connection part. And that should increase the performance. Accounting, like I said, enables the usage tracking. When it's enabled on a server, that will be the repository for that information. Each session that is established can be fully accounted for and stored on that server. It can be divided out so that it's done a different way or in a different place. Once it's enabled, that default accounting method will automatically be applied to every interface, except any that are user-defined or custom or have been specifically defined. As with authentication, you can use the word default for a list. Then you can record things like the type or trigger. That just means what is going to be recorded. Any questions on AAA and Cisco? Yes, that's what it means, is that you can configure with with TicTacs Plus, you can configure the different A's to respond to different servers or different ways. Yeah, so it could send those specific things in different packets to different servers. So if you wanted your authentication to be one, you wanted your authorization to be another, you wanted your accounting to be yet another, you could do that. Yes, it could be more work. On the flip side, if you do split things up, like let's say you split up logging, and a attacker is able to get into, let's say, the router, they won't be able, ideally, won't be able to get into the accounting server and erase their tracks, because logging will be different. So even though they were successful to get in, they are unsuccessful in removing evidence that they made it in. Yeah, don't just discount it as, oh, it's more work. It's more work for a reason. A reintroduction to access control lists. Just as with any platform, an ACL is a series of commands to filter packets based on information found in the header. This packet filtering occurs at layer 3 and 4. You can do it at both, at one or the other, but the router will take out, either continue the packet or discard it based on any given criteria. Correct. Sockets. Any ACL with the number 1 to 99 or 1300 to 1999 are considered standard ACLs, while anything 100 to 199 or 2000 to 2699 are called extended ACLs. Naming ACLs is the preferred method for configuring. You can name them in order to provide more information on the purpose of that access control list. And that's good because it'll help anybody else, any other network admin, when they access the device and go, why is this rule here? If you have it named, it'll help them understand what's going on. Always a good thing. Like I said, ACLs will define the set of rules that'll give added control for packets that enter inbound interfaces, packets that relay through a router, and packets that exit outbound interfaces on that router. An inbound ACL will filter packets before they are routed to the outbound interface. As long as the packet is permitted, it's processed for routing. Inbound ACLs are best used to filter packets when the network attached to an inbound interface is the only source of packets that need to be examined. An outbound ACL filters packets after being routed, regardless of the inbound interface. Incoming packets are routed to the outbound interface, and then they are processed through the outbound ACL. Outbound ACLs are best used when the same filter will be applied to packets coming from multiple inbound interfaces before exiting the same outbound interface. For wildcards, although a wildcard mask is like a subnet mask in that it uses the AND process to identify which bits is in an IPv4 address to match. As usual with a subnet mask, the wildcard just means anybody in that range. Here's 3 examples to refresh your mind. Calculating wildcard masks can always be challenging, but thank goodness that you can just search online on how to do them. Because you could take something like this and run it through one of those calculators and get your answer. Taking things like that, you can slip it into an access control list like this. You have the host, substitutes for the 0 mask. This mask states that all IPv4 addresses must match the filter just to one host address. There is the any, which substitutes for 255 4 times. This mask says to ignore the entire IPv4 address or to accept any addresses. So while both of these are completely legit ways of writing the same, this one is obviously a much cleaner way of saying the exact same thing. When configuring a complex access control list, you'll need to use a text editor to write specifics on the policy, add any iOS configuration commands, include remarks to document the ACL, copy paste the devices, the commands into the device, and then test, of course. If you wanted to test or create a numbered standard ACL, you would use this command shown. If you do no access list and then the number for it, then you could remove that ACL. This table here shows you a detailed explanation of the syntax for a standard ACL. ACL names are alphanumeric, case sensitive, and have to be unique. Capitalizing ACL names is recommended. You could use this first example in global config to create a standard ACL. In this example, we have one called no access. You'll see that global config changes itself. So you know that you're working with ACL specifically. Making extended ACLs is the same. When it is first configured and activated on an interface, you'll have more complex things to do. This first example is creating a numbered extended ACL. And then to apply it, it's the same thing as a standard. With an extended, you have more options. So not only do you have these that are similar to the first, but logging isn't here. Well, further down, you have more options. The 4 highlighted protocols here in this picture are the most popular to create an access control list for. As always, you can use the question mark to get help when entering any complex access control list. You could even, instead of using the IP protocol name, you could use a number. So like 1 is TCP, 6 is UDP. Oh, sorry. ICMP is 1, TCP is 6, UDP is 17, and there's 255 to pick from. When it comes to ports, you have the full range. There are some ports where the name isn't given, so you'll have to use the actual port number. Extended ACLs can filter on different port number and different port name options. This example configures an extended ACL 100 to filter HTTP traffic. The first one is uses the port name. The second will use the port number. Both of them do the same exact result. Using the port number is required when there isn't a specific protocol named, like SSH or HTTPS. TCP can also perform basic stateful firewall services using the established keyword. The keyword enables inside traffic to exit inside the private network and permit the returning reply to enter inside the network. Any TCP traffic generated by an outside host attempting to communicate inside will be denied. This way, only the return traffic is accepted and everything else is blocked. So if the device didn't request it, it's not coming through. Here we have an access control list of 120, and it only permits returning web traffic to the inside host. It's then applied to the interface G000. The show access list command will display the running ACLs. And you see once it's running, how many times that rule has taken effect. As I said, giving them a name helps rather than remembering 120, 110. That could mean anything. Putting a name is definitely useful. in helping not only your future self from remembering what this rule does, but also anybody else working on the device later. Named extended ACLs are created in essentially the same way that the standard ones are made. We can make a rule that will permit inside HTTP and HTTPS traffic to exit to the internet. And we can enable a browsing rule that'll permit web traffic to the inside host while everything else is implicitly denied. That would look like this. You have the surfing ACL permitting HTTP and S traffic from inside users to exit the interface. Any web traffic returning from the internet is permitted back in by the browsing ACL. Once they're configured, you may need to modify them because that's what you should do. You should always test, make sure your rules are accurate. If they're no longer accurate, you make adjustments. Any ACLs that have multiple ACEs will be complex to configure. So you'll need to do some trial and error before those rules are tuned just right. Any ones that have multiple rules, any access controllers that have multiple rules within them, you should use something like a text editor to fix. So you make those changes there, and then you copy paste the edited rule back in. You can always delete or add using sequence numbers. And use IP access list standard to edit an ACL as well. Once you've made and adjusted them, you can implement. So you create that ACL, you apply it, you ensure that the last statement is an implicit deny any or deny IP any. Remember that statement order is important because ACLs are processed top to down. You remember that ACL, it's only one per interface per protocol per direction. New statements for any existing ACL are added to the bottom by default. You want any standard ACLs ideally as close to the destination as possible, and any extended ACLs as close to the source. Any router-generated packets are not filtered by outbound ACLs. Once created, you can apply them in a different way, in any different way, to whatever interface you need. Here is one for outbound traffic. Here are the two extended ACLs for surfing and browsing. Here's one applied to the VTY lines. Like I said, you want to put your ACLs in a place where they are most efficient. The usual objective is to prevent traffic that originates from a network to reach another. So we want to find the best place to put them. And of course, it depends on a variety of factors. You don't just slap an ACL anywhere. You factor in the effect. You factor in any pushback to decide what the best place is. Following a guideline for ACL placement, your standard one should be located as close to the destination as possible. Like I said, your ACLs, extended ACLs, you want to put them as close to the source, preventing unwanted traffic to be sent across multiple networks, only to be denied when it reaches the destination. ACLs are great to mitigate attacks like spoofing. IP address spoofing overrides the normal packet creation process by inserting a custom IP header with a different source IP address. There are many well-known classes of IP addresses that should never be used in a traffic. In this case, the S and 30 interface is attached to the internet and should never accept inbound packets for anything that is all zeros, anything that's broadcast, any local host addresses, anything under a PIPA, anything reserved, and any multicast. All those things should be set up to prevent them from going in. An effective strategy for mitigating attacks is to explicitly permit only certain types of traffic through a firewall, like DNS, SMTP, and FTP are all examples that often must be allowed through a firewall. SSH, syslog, SNMP could be included or could also be prevented from contacting the outside world. ICMP, echo and redirect messages should be blocked inbound by the router. You don't want an attacker to use ping to find out what's on the other side. Right, you only want to let certain ports in and block everything else. Things coming out of your network are usually safe, but things coming in, not so much. If your SNMP is listening, that could be a problem. If a device is not meant to have that listening, then just turn it off. Same rule with anything else if it's not necessary, turn it off. So that is all IPv4. We have to mention IPv6. These attacks are more pervasive. IPv4 is not disappearing overnight. The two are coexisting, and someday v4 will finally die and we'll only have v6. Threat actors can accomplish stealth attacks that result in trust exploitation by using dual stacked hosts, rogue neighbor discovery protocol messages, and tunneling techniques. So we do have to make IPv6 ACLs. The functionality is just the same in either. There is no equivalent IPv4 standard ACLs. Any v6 have to be configured with a name. They allow filtering based on source and destination addresses that are traveling inbound and outbound to a specific interface. They support traffic filtering based on v6 option headers and optional upper layer protocol type information for finer granularity of control. So you use the IPv6 access list to get into that mode. You can apply in a v6 ACL with IPv6 traffic filter command. Here are some things that show up in the syntax for making an IPv6 ACL, very similar to v4. Lastly, an IPv6 ACL contains an implicit deny v6 any command. Each v6 ACL also contains implicit permit rules to enable IPv6 neighbor discovery. The NDP requires IPv6 network layer to send network advertisements and neighbor solicitations. If an admin configures the deny v6 any command without explicitly permitting neighbor discovery, then NDP will be disabled. In this example, R1 is permitting inbound traffic on G0 from that IPv6 network. NA and NS packets are all explicitly permitted. Traffic sourced from any other IPv6 address is explicitly denied. If the administrator only configured the first permit statement, then the ACL would actually end up with the same effect. It is always good practice to document implicit statements by explicitly configuring them. Any questions on access controls? Access control lists. I mean, I would block ping packets. And if my router doesn't need to know the neighbors, then I would block that too. My basic rule of thumb is if it's not important, then I'm going to block it. Right. For work this week, there are actually a number of packet tracers to get through. So we'll be spending the rest of the time working through those packet tracer files. As usual, I'll stop the recording now so that we don't record dead air. And also live on Discord if anybody has questions.